Hi, I'm Carrie Lebowski. I'm a professor of soil science and extension soil fertility and nutrient management specialist. In this segment, we're going to be talking about soil sampling. Now, there are a few goals of soil sampling. One aspect is that we want to collect a sample that represents a field or a portion of the field. That is super important. It needs to be representative. If it's not representative, it's pretty much not useful. We want to be able to estimate the nutrients needed for economic crop production. We want to gain an understanding of the nutrient variability within the field. That's really important, and there's certain types of sampling methods that allow us to gain a better understanding of variability than others. And soil sampling can also be a good way to monitor the nutrient status of the soil over a period of time, particularly if you have a good track record of taking samples every 4 years over 20 years time period. You've got at least 5 sets of samples to be tracking how things are going on your farm. So first off, let's talk about when to sample. If we think about soil tests themselves, typically we can see a little bit higher pH, P, and K in the spring compared to the fall. Not necessarily, shouldn't really be lots of big differences, but they can tend to be a little different. We tend to see that soil test levels rebound over time as nutrients move from one pool in the soil to another pool. So, as you have a crop growing all season long, it's extracting nutrients, so you need to be recharging that soil solution pool of nutrients. And that's what's happening when you get some differences between fall and spring. Now, typically, fall sampling generally provides more conservative or larger fertilizer recommendations, because sometimes your soil test levels might be a little bit lower. And we need to keep in mind that we can see overwinter changes in soil test K. They can be dependent on clay mineralogy and also the soil test level. Okay, so some clays upon freezing and thawing will release potassium, others will fix potassium. Sometimes there's some differences whether you have a very low soil test value versus an excessively high soil test value. And we also have to keep in mind when harvesting in the fall time that soil test K is going to vary depending on how soon after the combine's gone through the field that you take samples. So if you essentially sample right behind the combine, you might have a lower soil test K value than if you sample 6 weeks after the combine's gone through the field and we've had some rainfall. And that's because the potassium that's in crop residue gets released as the residue starts breaking down and you get rainfall on it. Potassium will leach out of the residue. So because of that, you can see where it's an issue for how quickly behind the combine you go. Now, if you have, say, a corn silage crop where you don't have a whole lot of residue out there, there's probably not going to be a whole lot of difference depending on whether you sample right after silage or wait a little bit. But when you start talking about just corn grain production or soybean production, that will make a little bit of a difference. So one of the key things is to be consistent with the timing of when you sample as much as possible. If you sample certain fields in the fall, if you're always doing them in the fall, the data over time will be a little easier to compare than if you have some samples in the fall and some in the spring. Now we know that weather doesn't always cooperate with us, and we could want to sample in the fall but not be able to. So sometimes we do have to have that mixture between seasons. And in general, keep in mind that sampling frozen ground is generally not a good idea. Once we get frozen, whether that happens in November or December, continuing to sample we usually get poor samples. And then that's the main reason not to sample frozen ground is it's hard to get a good sample where you're getting accurate depths and consistent depths. Now, just a quickie here on how to actually take the soil sample. So what you want to do is for a sample, you'd take about 10 to 20 soil cores. So you'd have your soil probe, and you take 10 to 20 cores, and you put it in a bucket, and then you want to very thoroughly mix it. Here's the key. You've got 20 cores, and that's a fair bit of soil compared to the little soil bag you're going to put it in. So you may not be able to put all of that soil in the bag. So you want to mix that as thoroughly as possible to create a composite sample. Okay, and remember, when you're taking your cores, you want to sample to a consistent depth. That's extremely important, because if sometimes you're putting the probe in the ground 6 inches and other times it's 8, and then occasionally it gets to 4, you're going to get goofy numbers, because in general, as the deeper you go, the lower the nutrient concentrations you tend to have. It's not necessarily the gospel, but that's what tends to happen. So if you keep sampling deeper, you may have a false sense of a lower soil test than what's actually true. Or if you tend to sample shallow, you might get a false sense of a high soil test. So now, once you've thoroughly mixed your sample in the bucket, you want to take about 2 cups of that soil and put it into a sample bag. And so it's pretty straightforward. Please make sure you clearly label your sample bags. Different businesses have different ways of doing it. Some have barcodes, some have other kinds of stickers, some have coding schemes, and then you got other people that are just handwriting on the bag. The key is so that you know what field that sample came from and what number in that field and where in that field that sample came from. Because if it comes down to it is, if you don't put enough information on there and that you haven't written that information elsewhere, you might not really know where the sample came from. Now, another thing as you're taking the sample is mark the location of the sample on a map. If you're doing this by hand, some folks are still doing that, or with GPS waypoints. So this could be live on the go that you're doing this. You could also have previously set up, while you're in the office, sampling locations with GPS coordinates, so that when you hop on the ATV, you're just driving to a GPS coordinate, and that's already preset. So there's a couple ways to tackle that, but the real key is to know where that sample came from, or what part of the field it represents. And then when you get to the point of sending the sample into the lab, make sure you fill out the soil sample submittal sheet correctly, accurately, and completely. The more information you provide, the better the recommendation you're going to get. If you don't provide very much information, you're going to get a much more generic recommendation that might not be as applicable to your field. Now, where to soil sample? That's important. We've got a few different soil sampling schemes that people might use. We have the whole field method, the grid method, and the zone approach. And we're going to go through each of those in a little more detail. And it's important to know that which method you choose is really going to be determined by what you're going to do with the information. And if you plan to do variable rate application, that maybe suggests a grid or a zone approach and not a whole field. You might also think about sampling history. If this is a field where you've never farmed it before, it's a brand new rental piece of ground, you don't have much information about it, maybe a grid type sampling would be important to start with, so that you can get a better sense of variability. And you might think about that differently than if it's a field that's been in your family for 100 years and has been sampled many times in the past, and you kind of know what's going on. And also, we can think about a little bit with the existing fertility level. If you have, the last time you tested everything was excessively high, you might want to think about how you sample a little differently than, because your recommendations are going to be small or none, and that would mean you should think about it differently compared to when your soil tests are, say, low or very low, when you have much greater nutrient recommendations. So let's move into the whole field approach. This is used where essentially a single fertilizer recommendation is going to be applied to a field. Okay, so there's only going to be one application rate. This is typically considered conventional sampling. On the plus side is it's relatively cheap. When you're doing it right, it doesn't cost so much, you don't need as many samples. The big minus to this approach is you don't really have very much information about nutrient variability within the field. So that's different ways to approach it. So now with our whole field sampling, we need to think about sampling intensity. So we have this table broken up a little bit with some field characteristics. And if we start with fields that were tested more than 4 years ago, or fields testing in the responsive range, okay? And what does responsive range mean? Well, responsive range is where either soil test P or K are in the high category or lower. We're going to have nutrient recommendations here. So this is the responsive range. It doesn't matter what size field you have. The suggested number of samples to take is 1 sample per 5 acres. Okay, so if you have a 20-acre field and you want to sample this way, 20 acres divided by 5 acres, that would mean you'd take 4 samples in that field. Now, another way to look at this is field characteristics. Is the non-responsive fields, okay? And what does non-responsive mean? Well, if you go to the bottom, non-responsive is where both soil test P and K are in the very high or excessively high category. So typically, excessively high, we're not going to have a recommendation for any nutrients, and very high, it would be a small recommendation. And when we have our sampling for whole field type approach, and we're in the non-responsive range, the last time we tested, you can see that if we can alter the number of samples taken. And essentially you're reducing the intensity of sampling. And the reason for this is last time it was sampled, everything was really high. And so if you've been maintaining your nutrient applications, it's probably going to be relatively high still, so you could probably back off a little bit. Now, for the whole field approach, you want to avoid, since you're trying to manage the whole field, you want to avoid unusual areas. Okay? So unusual areas, dead furrows or back furrows. You don't see too many of those out there, but there's still a few moldboard plows. Any place where anything's been piled, whether it's manure, lime, sludge, stay away from places where anything was piled. Even if it was piled several years ago, that will still show up. Avoid near fence rows, avoid right up against roads, particularly where you might have road salt moving into the area. Eroded knolls or low spots in the field, and if you can try to avoid rows where fertilizer has been banded, stay out of the band. Now, one thing to keep in mind is if these distinctive areas are large enough, then you might want to sample that separately. But if you're really talking about this 100 square foot area in a field, or maybe out of a 20-acre field, it's barely a half acre in size and it's in 2 different pockets, maybe you just avoid it altogether. It's up to you, but if it starts getting larger, you should probably consider some of these odd areas to maybe not be so odd, and you just have to separate it out as a separate sample. So now with this whole field approach, this is an example of a field that's 15 acres in size. So for the 1 sample per 5 acres, that means we would take 3 samples in the field. And so we have rough kind of boundaries, dividing the field into 5 acres parcels. And you just start going through, and we walk a W pattern, right, for Wisconsin, and pick up soil samples along the way. So each of these squares represents where you'd stop and take a core. And once you get to the end, you've got this bucket full of 10 to 20 cores. You mix them up, and that creates 1 sample. And so you go through and do that. So you can see as you're crisscrossing this 5-acre parcel, you're taking some cores randomly throughout. So you're trying to make a composite that's as representative as possible of this whole 5-acre piece. Now, if we move into grid soil sampling, this is used where you're going to be applying nutrients variably. As I briefly mentioned before, it's very important if you're looking at purchasing new ground, renting ground that you haven't had, the past isn't well known. It gives you a good sense of variation in soil test levels, so you can make a decision about what you want to do about that. Some of the pluses of grid sampling is it is a pretty good assessment of nutrient variability when it's done properly. The minus is when done properly, it's expensive. So there's some distinct trade-offs here. Now here's an example of grid sampling. So we have a field that's divvied into grids. Now you can see I've got these little boxes, black boxes in there. And so what we suggest is that when you are doing a grid sample, you don't take the center point of each one of these little parcels and have that be the place where it's sampled. You want to offset them and move them around. And the reason for that is, we have a lot of linear features in a field. So if we think about the tractor going up and back and the combine going up and back, it's possible that if we had all of our sampling points lined up right in the center area, we might be in some place where we've artificially created something different that doesn't exist if we move over 20 feet, 30 feet one way or another. It's just something that happened during a particular pass of an implement. Now, when we look at grid sampling, so what I just described moving these points around is what's called unaligned. But the grid size is really important here. And if you note, I've got this in orange, so it calls your attention to it. We suggest using a 300-foot grid. So this would be like a 2.1 acre grid if both P and K are in the non-responsive category. So this would be very high, excessively high soil test level. That's based on the previous time you sampled. Now, if the previous time you sampled soil test levels were high or below, okay, so that's the responsive range, we suggest a grid size of 200 feet or a 0.92 acre grid. Okay, so much tighter. And the reason being is there's going to likely be more variation in soil test level when we have lower soil test levels where you're going to need nutrients, and that those changes, say between a soil test that's testing low versus one that's testing optimum, that can make a huge difference in a recommendation. So you want to have a tighter grid to more accurately characterize variability. Sampling on 5-acre grid points, because some folks are doing that, they take the sampling intensity for whole field, 1 sample per 5 acres, and just say, okay, this is my 5 acres, and I'm going to take my sample right in the middle of it. That doesn't do a very good job. That's really too large of a grid to accurately capture variability. Now also, when we are taking these grid soil samples, is when you get to your location here, and say this was predetermined in the office, that's where you're going to soil sample, you drove the ATV out there, you want to take about 10 cores. You could do 20 if you want, but probably 10's a good minimum number, and composite them. And those cores you want to take in about a 10-foot radius from the grid point. So not an overly large area, but not a really tiny one either. And again, you'll have the GPS coordinates with that so that you can go back there time and again. Of course, how accurate it is related to the accuracy of the GPS that you're using. Now, this gets me back to this 5-acre grid point sampling that I just briefly brought up. I'm generally not a fan, but it could potentially be used if you sampled the fields less than 4 years ago. Well, I see here less than or equal to 4 years ago, and the previous soil tests were in the non-responsive range. Maybe you'd want to go that far. Really, you're just not capturing variability very well. But I really don't think you should use a 5-acre grid point sampling if you can't meet these criteria. The reason being is this type of sampling does not adequately represent variability within the field. And if our goal is to put on variable rate applications, then we need to do that. Now, the other thing is it doesn't accurately represent the field is if you're going to do whole field management. If you use a 5-acre grid point to take samples, so say your 20-acre field, 5-acre grid points, that would give you 4 samples per field, and they're just 4 quadrants that you sampled within 10 feet of that point. That's not giving you a very representative soil sample for that whole 5 acres, so that's not going to do very well on a whole field management as well. Now, moving into the zone management approach, this is where you might create some different management zones across a field. Okay, so it's one way to look at it is it's maybe a bit of a hybrid between the whole field approach and the grid approach. Now here the zone borders and sampling points can be georeferenced. I suspect that most people are georeferencing that now, but you don't have to have all the technology to do some of this. You can kind of eyeball certain features in the field and for where you're going to create some zones. Now there's a few pluses and minuses to zone sampling. Zone sampling itself provides a good assessment of variability, better than whole field, but not as good as grid. So it's kind of in the middle for assessing variability. And it can be cost effective. Kind of that balance between the cheapness of, say, whole field approach versus the more expensive 1 acre grid sampling. Now the key here is delineating zones that are going to be useful, and also from the standpoint of managing differently within the field. And so you could delineate zone based on your knowledge of what's happening there. Are there differences in soil types across the field? Do you have yield maps that show some sort of consistency in yield variation between areas of the field? You could use topography maps. Past history is really important as well. If you know something's happened before, for example, if you have a fairly large field that at one point in time had been 2 different fields, maybe you want to sample that or call those different zones. And then another approach would be as if there previously had been grid sampling on the field, and you could see some things showing up in that grid sampling map that would suggest there are some zones. Maybe you want to then back off and do a zone approach. So when you're sampling with zones, you want to use the sampling intensity of the whole field approach, 1 sample per 5 acres, considering a zone of field. So when you think about it that way. And just here's some few examples of different types of zone delineation. We have differences in soil type across the field, places where we had lime versus no lime in the past. The example I previously gave, 2 fields are now 1. This happens frequently. You've got manure was applied last year versus no manure. You got manure out and then the snow got too deep and you could never get to the back part of the field. Be thinking about that, but then also looking at soil drainage classes, slopes. Some folks are using maps of electrical connectivity where there's some larger differences occurring. They'll break out some zones, particularly if they're overlaying that on some maps of soil series throughout the field. Now that brings me to sampling contoured strip fields. We have a number of places in the state of Wisconsin where we have contour strips. Now, when you think about these strips, some of them can be kind of small in size. They're just kind of little strings going around the contour of the hills. And so if the strips are greater than or equal to 5 acres, then you sample the strip separately. Again, using the whole field sampling intensity guidelines of 1 sample per 5 acres. If the strips are less than 5 acres in size and they've had the same cropping and management histories, then you can combine them together. So maybe you've got, 3 2-acre strips. Well, combine those 3 together and then call it 1 sample. So you'd pull, maybe here's where you might want to have more cores. Maybe you're pulling 6 cores off of 1 strip, 6 cores off the 2nd strip, and 6 cores off the 3rd strip, combining them all together for sampling. Grid sampling contoured strips becomes quite difficult. You need to make sure the sampling locations are actually in the strip. And I don't know, and it's hard to say that that's a good idea. I think it can be done, but you're going to need a lot of sampling points that a lot of people don't want to do. And I've seen grid sampling of contoured strips done very poorly, where the samples were essentially taken on the right on the contour, where you're switching from one strip to another, and that's not providing good data. In that same example, there were strips that were never sampled at all, and some that had a lot of samples taken in them. So you need to really think about making sure that each strip is the soil in that strip is accurately represented in your soil sampling scheme. Now, some other situations related to soil sampling. If you have high-value crops or crops with high nutrient removal, so high-value crops, maybe they'd be potatoes or sweet corn, Alfalfa has a high nutrient removals, corn silage. Maybe you want to be sampling more frequently because it's the higher value crops. They're very important. Soil testing's very cheap compared to the value of the crop, so you might want to stay on top of that more. And with crops that have high nutrient removals, soil tests might be changing a little faster than with others, so you might want to stay on top of that as well. Now, with grazed pastures, you want to be aware of variability. We have a newer, a couple-year-old bulletin on soil fertility guidelines for pastures, and that kind of outlines some things to be aware of with regard to staying away from certain areas within a pasture. And the other thing is fields that don't quite meet the sampling intensity requirements. You need to be careful. You know, soil testing and sampling, it really is very cheap. It doesn't cost much per acre when we think about all of our other inputs. So, you know, I would suggest erring on the side of taking one more sample. If you're not quite certain, one more is better than having one too few. So if you need more information on soil sampling, look at Chapter 2 in Publication A 2809.